We have been told a comforting lie about how artificial intelligence learns. We picture pristine labs where elite engineers patiently teach machines right from wrong, correction by correction, like teachers grading a test. But that is not how it happens. The systems shaping our world are not trained by us. They are educated by the chaotic, uncurated, and often ugly noise of the raw internet. And we are just starting to realize what they actually learned. Every time you interact with a state-of-the-art artificial intelligence, you are not talking to a system that was taught how to think by humans. You are talking to a statistical mirror of our collective, unfiltered history. The human guidance we hear so much about is not the education. It is merely a polite mask. To understand how this works, we have to strip away the human-like metaphors. At its core, a large language model does only one thing. It takes a sequence of words and predicts what word comes next. If you give it the phrase, "the sky is," it calculates the mathematical probability of every word in its vocabulary. Blue might have a 90% probability. Cloudy might have 9%. Obsidian might have a fraction of a percent. There is no human supervisor telling the machine why the sky is blue. No one programmed a rulebook of physics or grammar into its chips. Instead, the machine reads petabytes of raw, unlabeled text. By playing this guessing game billions of times, it forces its own neural network to adjust its internal wiring to make better guesses. This is self-supervised learning. It is a brutal, relentless process of trial and error driven by a single mathematical objective: minimize the surprise of the next word. Imagine you are locked in a dark room. On the wall, you can see only the flat, two-dimensional shadow of a rotating three-dimensional object. You have never seen the actual object itself, and you do not know what it is. Your only job is to predict the exact shape of the shadow in the next second. At first, you make wild, terrible guesses. But over time, you notice patterns. You realize that to accurately predict the flat shadow, you have to mentally reconstruct the three-dimensional shape that is casting it. This is exactly how an artificial intelligence builds a world model. The raw, unlabeled text on the internet is the flat shadow of our complex, multi-dimensional reality. To get exceptionally good at predicting the next word, the model cannot just memorize text patterns. It is mathematically forced to build an internal, functional simulation of the physics, logic, and relationships of the world that generated that text. We saw proof of this when researchers trained a model purely on the text of Othello game moves. The model was never given the rules of the game, nor was it told what a game board looks like. Yet, when analyzed internally, scientists discovered the model had silently constructed a perfect virtual map of the 8x8 board and the state of every piece, solely to predict the next written move. But in July 2026, the artificial intelligence industry is running into a catastrophic wall. We have run out of high-quality, human-written text. For the past decade, AI labs have treated the internet like an infinite resource, scooping up every book, scientific paper, blog post, and social media comment they could find. Now, the clean reservoirs are empty. To keep scaling, companies are being forced to feed their models raw, uncurated web dumps, forum arguments, and synthetic data generated by other machines. This means the hidden curriculum, the silent lessons embedded within raw, unorganized data, is becoming the primary driver of future machine intelligence. And when you train a system on the raw, unedited exhaust of human civilization, it learns things we never intended to teach. Many believe that a process called reinforcement learning from human feedback, or RLHF, is where AI becomes smart and safe. This is the stage where human testers grade the AI's responses, rewarding it for being helpful and punishing it for being toxic. But this is a massive misconception. Landmark research, including the famous Lima study, has shown that alignment tuning does not teach the model new capabilities. Almost 100% of the model's knowledge, reasoning ability, and world model are built during the unsupervised pre-training phase on unlabeled data. Alignment tuning is merely a superficial paint job. It teaches the model the style, format, and tone that humans prefer. It teaches it to say please and thank you, and to structure its answers in neat bullet points. But underneath that polite, corporate veneer lies a massive, untamed base of knowledge built entirely by the hidden curriculum. And that base is highly volatile. To see how dangerous this hidden curriculum can be, we have to look at what happens when an AI reads our raw, real-world data. Consider a medical AI trained on millions of unlabeled clinical papers, dietary guides, and health records. On the surface, it seems highly capable, but a deeper analysis reveals a silent, systemic bias. Research shows that cardiovascular diseases like atherosclerosis are heavily driven by dietary factors. Yet, our global food systems have over $13 trillion in hidden socioeconomic and environmental costs, leaving vast populations unable to afford healthy food. Because the raw text in our medical systems is written by and for a system that prioritizes high-cost clinical treatments over fixing food inequality, the AI silently absorbs this structural class bias. It does not just learn medicine. It learns to recommend hyper-expensive, resource-intensive interventions. It treats the structural inequalities of our society as if they are unchangeable laws of human biology, because those inequalities were baked into the unlabeled text it fed on. As we enter the era of the data wall, labs are attempting to bypass the shortage of human text by feeding models synthetic data, which is text generated by other AI models. This creates a dangerous feedback loop. When an AI is trained on unlabeled data that is itself the output of another AI, the subtle distortions, errors, and biases of the previous generation are amplified. In computer science, this is known as model collapse. The rich, diverse, and messy nuances of real human language are slowly ironed out, replaced by a bland, hollow average. By trying to bypass the hidden curriculum of human experience, we risk building machines that are increasingly confident, yet increasingly disconnected from reality. The ultimate truth of the hidden curriculum is that we cannot build a machine that is cleaner than the data we feed it. We want our artificial intelligence to be a flawless oracle, a perfectly objective thinker that rises above our flaws. But the mathematics of self-supervised learning make that impossible. The machine learns by finding the deep structure within our actual, messy, unfiltered history. If we want machines that are fair, wise, and just, we cannot rely on a superficial layer of human feedback to paint over the cracks. We must reckon with the curriculum we have written for them. Because in the end, the AI is not a separate mind. It is a mirror, and it is showing us exactly who we are.